Thank you very much. So for the next half hour, I'm going to talk about what's new for Oracle database in the latest .NET release, .NET 9 and EF Core 9. And for Oracle, we're you probably know us from being in the enterprise, but we also work with a lot of development technologies. And my development team has worked very hard in integrating a lot of the new .NET 9 features and especially the EF Core 9 features, which provides a lot of new data access capabilities. So I'm Alex Key. I'm from Oracle. I'm a product manager here, and I will go through some of these new features that our database works with, as well as show you how to kind of quickly get started using Oracle. And everything I'll be demonstrating is free for developers, from our data provider, odp.net, to our developer tools in Visual Studio and VS Code, as well as we have a free version of the Oracle database, both in the cloud, the autonomous database, as well as on-premise, which we call database free. So with that, let's proceed. Next slide. Okay, so I'll give you a brief history of Oracle database for .NET, how Oracle has supported .NET um, from the last over 20 years now till now, and then just give you a quick history, and then we'll talk about some of these new .NET 9 features that the Oracle database supports. And then we'll talk about EF Core 9. I'll do several demos, and then we'll wrap up with, if you are kind of new to Oracle and want to get started with it, how to get onto an Oracle database, either on the cloud or on premises. Okay, so let's talk about our database support for .NET. So we've supported .NET for a long, long time. I mean, even before .NET, we were supporting Microsoft COM and OLADB. But 2002 was the first year we released our data provider, Oracle Data Provider for .NET, or we call it ODP.NET. And then a couple years after that, we supported Visual Studio with a set of tools that give you some design time, ability to change your schema, do queries, even debug your stored procedures. And then in 2011, we supported the entity framework, for which I call Classic, which is, for nowadays it's Entity Framework 6. And then in 2018, we supported ODP.NET Core for the .NET Core runtime. And then later that year, we supported EF Core after that. And then in 2019, we provide the same plugin we did for Visual Studio, but this time for VS Code. And then to this date, this month, we are now supporting .NET 9 and EF Core 9. So let me talk about some of the new .NET 9 features you can take advantage of with the Oracle database. In terms of certification itself, our ODP.NET Core version that we will have certified with .NET 9 is the 23.6.1 version, and that's already available today on NuGet Gallery. Since .NET 9 came available Tuesday for everyone, we're still doing some certification testing on it, and we should complete it by the end of this week and have official certification of ODP.NET Core for 23.6.1 for .NET 9. And we've been testing it throughout all the release candidates and early drops, so we've made sure that any bugs we see get fixed. So we are pretty confident this 23.6.1 version is going to be able to be certified without any issues, and you should be able to use it today and not have any problems with it. And then, of course, one of the big things that a lot of developers are talking about, and Microsoft is making a lot of support for, are AI applications and vectors, and tensor data types and things like that. And you can use .NET 9 tensor and vector types with Oracle database vectors in your .NET AI app, so they are interoperable, so they shouldn't have any problems. And my team is working on building connectors for Semantic Kernel, which is Microsoft's LLM framework for their AI apps, as well as LangChain.net, which is a popular independent LLM as well. And having those connectors work with the Oracle database so that you can build AI apps in either of those frameworks and be able to use an Oracle database with them very easily. A couple other features is our Oracle data source. This is the DB data source, and we're going to first support this in .NET 9 with our upcoming 23.7 release of ODP.NET Core. that should be coming probably early next year. And this will, or actually might even come in December. So sometime in December or early next year. Uh, this will be supporting both DB data source as well as the DB data source builder, and you'll have that in .NET 9, and we'll also backport that to .NET 8, so that I'll show you a demonstration of that, and so that it makes it easy to build um, multi data source apps with it, so that you can go against different data sources if you want, as well as use more and more frameworks which are adopting the DB data source model when connecting to databases. TCP fast open, which is new in .NET 9. ODP.NET is going to support that also with 23.7. And then also, we introduced open telemetry last year, but we are continually adding new features to it in terms of new things you can monitor in your tracing. So today, you can already use it in your .NET apps for tracing of database round trips, database activity, as well as map things like your connection statistics, your connection pools with .NET metrics. And that's available with the Oracle Managed Data Access Open Telemetry NuGet package you can find there. So I talked a bit about some of these features. I know you guys are developers. You want to see some code. So let's look at some code. Let's start off with the Oracle data source. Since this is a fairly highly requested feature and it's going to work with .NET 9, let me show you some code for that. So here we are in some C# code. We can see that it is running in .NET 9. Perfect. And we are going to connect to the Oracle database and just use kind of these DB data source uh, uh, methods and properties and constructs in order to connect and retrieve some data. So there's a couple ways you can do it. One, you can use a factory class and create a data source. And you can see that it's just normal ADO.NET code, and we're not actually using anything ODP.NET specific here in terms of APIs. It's just standard ADO.NET code, so that it's very generic. We're going to retrieve the first name and last name from employees where department ID equals 30, a connection, a command, open the connection, and then execute the reader, and then read the results and output it to the screen. So very simple, very straightforward. We're just going to the Oracle database, and just to show you the tools, I'm actually connected to a free autonomous database. It's a 23 AI version of autonomous database, and we're going to connect to this employees table. And this employees table here, you can see the different employees, and we're just going to retrieve from department 30. So if I run this, we can watch the factory class in action. So it actually showed up on another screen. Here we go. So we see these are the employees from department 30. And I'll just run the second part of this application right now, which uses the data source builder to then connect to the database here. So we can see we can connect to the autonomous database with the data source builder. So if we look at that code to connect to data source builder, we can just see that it is very simple to use and the same. And the one thing that data source builders can do is use different connection properties on your ADO.NET connection. So in this case, for ODP.NET, we have our ODP.NET specific properties, things like pipelining, using auto commit instead of not having auto commit on, and keep alive settings. But you can set basically any Oracle connection property that's available. And so that allows you to customize your connection at the same time using the data source builder. So, so that was that. And let me go back to the slides. We'll go on to the next demo, which is AI vectors. And this, what we're going to do with this vector demo is we're going to load some data into the Oracle database using C# and ODP.NET. So we're going to do the loading, and then with EF Core 9, we're going to do selecting of that data, or I should say, we're going to do a similarity search. And with the similarity search, we're going to provide some text and find the closest match to that text among the existing data in the database. And AI is kind of big right now. And the thing about databases in the past was that it was always they were always extremely good at finding exact matches. And the real strong point of AI is that now, instead of just looking at exact matches, the databases are now going to get very good at finding similar matches, which is all that fuzziness that probably humans are better at than computers, but as we improve our AI models, we'll let the computers do that fuzzy matching for us. So what I have here is an app, and we're going to use the Onyx model since Onyx is, a popular framework, and I already have a embedding model pre-built. And what we're going to do is right now we have a table with an ID column and an info column, and the info column has a bunch of text, just text about things about cricket, about energy, about airplanes, about cars, and facts and some opinions. But we're going to use that as our data set, and we're going to provide terms to it to see which sentence or which row is the best match for that. So we're going to use AI to do that because we're not asking for a specific text. We're providing a piece of text and finding the most similar match to that. But first thing we need to do is vectorize this data, because right now this is all in text. A database or .NET doesn't understand necessarily what's similar or what's not. You kind of have to teach it. And first, what you do is use the embedding model to turn this text into vectors. So it's a quantitative representation of the data, and that way it can do vector distancing, use a vector distancing algorithm to see which one is the closest in terms of matching what the information you're looking for. So that's what this .NET 9 app is doing, is that we're going in to use this embedding model to do that match, to do the data load, and then we'll do the match in the EF Core app. Okay, so the things we're going to ask it to do is first we're going to select all the data, to retrieve all the data out into our .NET app, and then once we do that, we vectorize that text data, and then we'll update it back to the database into the V column, which is our vector column. So we're going to fill that now empty column with all the data for each row, and then where the ID matches the original selection. So that's how it's going to be in terms of the SQL. Just to show you in terms of the vectorizing, which is using Onyx, we're calling this get and batch embedding using Onyx procedure. And what it does is it just uses Onyx and an inference session here to then turn all that text into a vector. So here we're using tensor types, just another vector type native to .NET, and we're putting that into the Oracle database into its own vector data type there. And you can see that they have compatibility so that you can share the data between the two, .NET and the Oracle database data. So let's load this. So we'll run it. And after we run it, we should see that it's connected. It got the row count. It's reading the data, doing the embeddings, and then it updated the embedding. So it should be done. We'll take a look again at the vector column and see if it has indeed been updated. And what we should see are just a bunch of arrays on the right side under the V column to indicate all the text information quantized into a bunch of numbers. And we see that's happened here. You can see a bunch of vectors have been populated for each row that we have for the 50 rows here that we have. So now that we have the vector information, what we can do is now turn this into, we can do a similarity search on it. So I'm going to use EF Core for this. And since when we do the search, when we use the term that we're searching for onto our database, we're going to have to vectorize that. So we're going to have to use the same embedding model, and I'll enter in a term like plane or fast travel, and then it'll vectorize that one term or short term so that it can then do a vector distance operation to find which row most closely matches the data. And normally, you'd have a larger data set, but since I'm doing a demo, I'm keeping it small so that, when you do the load, when you do the search, it won't take as long. when using a laptop and a free database instance as compared to the large, extremely large data sets that you typically find in a lot of applications. So what we're going to do is we have this embedding model. We're going to ask it to enter text. And then you can see here we are vectorizing that text with that same procedure that you saw in the .NET 9 program. And then that we make that into our vector variable. We send it into our vector variable. And once we do that, we can then use call uh, create a variable called similarity search query, and in that we do our um, our language integrated query, our link, and then we do an EF functions, which is something new we're adding to our EF Core 9 implementation, and we have this EF functions vector distance, and that does the calculation for figuring out this one vector, which is here, that the user has entered, compare it to the vectors in the database in the vector column, and use the cosine distance metric to do it. And you can use any, we have a number of different vector ability to calculate vector distances. Cosine is one of them. And actually in production, we're going to change this from an enum to a string. So you're going to have a string instead of enum. But for right now, the drop I have is uh, uh, is a enum, but you'll find a string, and then we'll just take the top result from that. Okay. And from there, it'll just output that result here, and let's see it work. So if I run this, it'll ask me, I can move this over. So I'll ask about vehicles. Here's the text and find the closest match to the word vehicles here. And it'll come back and tell me Mercedes and BMW are car companies. So the word vehicles is not even in there, but the ability to infer the closest match text is that, because we had statements about all different things inside that database, but the closest match was this one about car companies. We can ask about, well, airport, anything matching airports. It says airplanes are the fastest public transport medium, so it equated airports and transport and airplanes in there. And then what if we entered in the term fast travel? And there the result is nothing can travel faster than speed of light. So that's a different row it inferred from the term fast travel that is the closest match. So it's using that vector distancing language integrated query to figure out which is the closest match based on the vectors, and this turned out to be it. So that very simply is it's kind of a quick demonstration using EF Core 9 on .NET 9 that and vector data types in .NET, as well as the Oracle database 23 AI, being able to create something quite simple in terms of a vectorized application. The hard part is getting the data, of course, but the easy part is building the app for it, because a lot of the tools are there for building EF Core apps and .NET. So let's go back to the slides. So that was the EF Core 9 part, and I just did this demo. So let's talk about EF Core 9 itself. So we've got a lot of different new support for EF Core 9. So a couple of them are group by and execute update. So we're supporting those capabilities with complex types. With Oracle EF Core, we prune unneeded SQL elements so that your SQL can execute more efficiently. We also allow ef.parameter, which gives you the ability to use a parameter inside your query. So instead of just being able to use ef.constant, you can use ef.parameter as well. And we also inline uncorrelated subqueries so that you can batch them together in a single round trip executing in the database. We have an async version of ToHashSet now, as well as when count does not equal 0, we optimize it so that it uses a SQL exists. Data seeding, you can now do data seeding inside your configuration of your model instead of having to do that as an after step. It can be part of your model creation. And then we also support the auto-compiled models so that you don't have to manually do the compilation. It's very useful if you have a lot of, if you have a very large model. We also make existing model building conventions more extensible, such as property mapping code. And then we also apply um, the apply configuration from assembly. You can call non-public constructors from it as well. So let's take a look at a few of these features. We'll start with the complex types. So group by and execute update. So there is, oh, I don't have it open. So I gotta open this up. No, I do have it open. Yeah. Oh, here it is. Just missed it. Okay. So let's see. Let's make sure I have the right. So this code is from Microsoft itself, and I've just adapted it to use Oracle EF Core. So you'll see this as part of Microsoft's EF Core GitHub repository. And we're going to do the complex types. So we'll do the group by first. So what you see here is that we're going to use this group by term in our query, and it's going to group by store addresses. And once it groups by store addresses, we can extract the postal code, and for each postal code, we'll publish the number of stores that are part of that address. So you can see how it's applied here with the query. And if we take a look at how many there actually are, we'll just scroll up to take a look. We have uh, P1, P1, so two P1s postal codes and three P2 postal codes. So let's run this. And it'll also kind of build the database as well. So it's a little bit slower than the other application just because it has to ensure created and then, well, ensure deleted and then ensure created so that it can build the database. And then once it builds it and puts in all the data, it can then do the query for it. And then we should get the result that there's two P1 postal codes and three P2 postal codes. Yep, there it is. Sorry, yeah, three P2 stores in the postal code and two stores in the P1 postal code. So that was quite simple. And the next one is the execute update. So here we're going to just insert this store address in, and you can see it's kind of very short address here, and nothing's more than 3 characters. And then we're going to modify it with the ability to update complex types with this new address and execute update async for that new address. So let's run this. Oops, actually, it's going to run I have to comment out here and uncomment this fella. And now I can run it. Almost forgot that step. Here's the execute update test. And it'll recreate the schema again, delete the schema, recreate it again, and then insert that one row. It actually should hit the breakpoint. And let me refresh this. Refresh. Oh, I lost the connection, so actually I need to refresh the entire connection. I haven't connected in a while. There it is. So I refreshed it. Let's open up and retrieve the data. So I haven't done the update yet. So you can see that this is the first entry when we created the database that was entered. And if I keep letting the application continue and I refresh it, it should have the updated longer address. So let me refresh it. You can see that it changed from that short address into the longer Beatley, Norfolk, Gresson Hall store address to use. Okay, and then let's do one more demo. and then wrap things up. And this is just the data seeding demo. So this is pretty simple to understand. I'll just show you the code real quick. So on configuring, as you're creating your database, or your schema, I should say, here you have the ability to use seeding or use async seeding, and they're basically the same. You can then populate your initial data set with whatever entries you want. So it's not anything special other than creating an initial data set. And if we run this, it'll then go create it. And great, it showed up on the correct screen here. And we should be able to see that one, if we go back to this Oracle blog entry, so the blogs and posts kind of schema that you've, at this point, is kind of canonical for EF Core sample apps will be there. So if we refresh this, oh, it's still building it. So refresh it again. Oh, there, finally finished. Okay, so we can build, oops, that's okay. Okay, there, right click and refresh. There we go. And if we retrieve the data, we can see, let me close this, that Oracle blog is right there. So as expected. So let's go back to the slides and wrap things up. Okay, so to get started with Oracle database, if you're a developer and you haven't used it before, we do have free databases you can use. One is the always free autonomous database you can get on the Oracle Cloud. That's very, very quick to set up. You don't have to install anything. It auto updates itself. You can use our latest software. And that's the one I used in my demos here. And then on-premise users, you can get the Database 23 free version on Windows or Linux. So with that, I want to thank Microsoft for hosting this presentation. I think it's a great thing for the community. And to follow up, here's some information. My email is in the lower right-hand corner, and there's a bunch of other resources along here. If you want GitHub, if you want Twitter, if you want to download, we got a couple NuGet packages you can download. But that's it. Thank you.